Hello and welcome. I'm Bill Wake. We're here working on a basic interpreter. Last time we spent a bit of time on the read eval print loop command line kind of thing. And this time we're going to go back and work more on expressions. They're kind of the biggest piece of the language. There's a lot of similarity among them. Plus is a lot like minus and so on. But I think if we can get the complete expressions going, we've got a good chunk of things, and that'd be good. We've done most of the operators. Let's see, minus, plus, times, divide, exponent. We've done those. We haven't done the three Booleans. And yesterday we finished up those relational operators. Let's see. So I think we're going to start by looking at some documentation. All right. Most of these we've used the precedence, the typical precedence, what is it, PEMDAS or something, parentheses and exponents, multiply, divide, add, subtract. That's how BASIC does things. There's a little bit of an anomaly that the exponents are left associative. Normally exponents are right associative, but that's fine. But yeah, hierarchy of operations 15. But the and or, I had a note that said they were below relop, which makes sense, but let me just verify that. This is Commodore 64 documentation. It's a little more explicit than some of the other. Let's see, 12, 15. Okay, hierarchy. There we go. Okay, yeah, so exponentiation is the highest. Then unary minus. Ooh, have we done that? Okay, let's make a test for that one. I think we put things in the other order. All right. Exponentiation has higher precedence than unary minus, and I'm very sure we haven't done that actually. Unary minus. So minus 2 to the 3 is minus 8. Okay. I don't remember the original basic article I was looking at. I think they said something about that too, but it struck me as a little odd there, and I guess it's the same here. Okay, but the big thing is not and or are lower precedence than the relationals. So you can say not A less than B, and that's saying A greater than or equal to B. Okay. And is lower still. So not A less than B and B less than C is A greater than or equal to B and B less than C, and so on. And an or being and being higher than or is kind of analogous to times being higher than plus, and there's some deep relationships between the idea of multiplication and addition and or. All right. And strings. We haven't done anything with strings yet. Okay. There's a lot going on in these expressions. You think it's not much language, but there's a lot there. Okay. So let's add this stuff too. Precedence. Okay. And we left off doing something. We should finish that. I guess that would be, relational operators, let's say. Okay, and what are we? Oh, we're in parse testing still, so we just barely got started. All right, so we are verifying that each relational operator let's see, check relational is up here. It it creates a program one relation two, and then it parses it and checks that the expression is what we'd expect from this thing. Okay, expression.make builds us a tiny tree with the operator on top and one and two on the left hand and right hand sides, respectively. All right, and I think what we'll find is our parser. If we can find our parser. Okay, here's token equals equals. All right, and it creates an op2 with the relationship. Expression handles things at the relationship level as of now. Um, and it doesn't handle less than and greater than or equal and all that stuff. All right. So, did we? I think we started to create. Yeah. Here's relops. Um, is tokens, right? So we should be able to compare within those. Okay. Um, so I guess I want to say if relops dot contains token. Okay. And so our op2, it just throws the token as the opcode, the operation. Okay. And we save it here, and then we can drop it in when we do that. I'm a little confused. Let's see. Oh, we already got left up here. Okay, yeah. You do the left sub expression. You find you have a relational operator, and you save that. Then you do the right sub expression, and then build up the tree that you get from that. And if there were no one, then you're just kind of passing the sub expression through. All right. And again, there's a lot of kind of conceptual duplication here. This one left does something, checks for tokens, reads it, builds the right tree, and all that. Same thing here, same thing here. We probably could generalize that some. The trick is, like, we'd have to pass in this method as well. Maybe we'll do that and just see what comes out of it after we get these things together. All right, but I think this is where we left off. That we were hoping this would work, and let's make sure. And yesterday I described interpreter, at least the way we're doing it. There's a lexical analysis which identifies those tokens, and we did that for these two character tokens, less than, equal, and so on. Then there's parsing, which builds the tree up that corresponds to the grammar that we're using and really deeply corresponds. I mean, that was kind of a major insight / progress in the 1960s, I guess you'd say, of compilers to kind of develop that theory out very completely. There were definitely signs of it earlier on, but they really put a lot of work in parsing in the 1960s. And the third phase is interpreting. So we build up a tree, and then the interpreter goes kind of node by node and does stuff. And we're to the point where we want to do the interpreter tests. Okay, why? I think Yoink and Xcode don't play well together, I guess is my conclusion. All right. So we've done a lot of, well, we usually do this with printing. Okay. And another option, let's see. Yeah. I guess it needs the parse to do the interpreting. Okay. And the parse. Let's see. I'm kind of wondering if I can go in at a little lower level and still be useful. I mean, evaluate, interpret. Okay. Yeah, interpret, because the expressions aren't a standalone statement. We need some statement to manage it, I guess, is kind of what it comes down to. All right. maybe I can slide this over here. Yeah, that's an improvement anyway. Okay, let's, well, this is, I kind of want to do the same thing I did. So if I extract this body, I usually call these check relational operator. Again, this is pretty standard technical term, I guess you'd say, for those things. I don't know if you'd use it normally. All right, and we'll take that. So I'm going to parameterize this test a little bit. I'm creating this little helper function. Now I got to figure out what's going in. Well, I don't care. Well, 10 equals 10. Okay. Do I need to do, well, this definitely comes. Let's, can I make a variable? Extract to a variable, and this is the op. And then I'm going to push it into the parameter and then put that down in here. That equals. Okay. And then take it out of here. Okay. So I'm using the parameter here and that. Now the answer, well, let's write another one and see what we think. Check print with rel op. Let's do less than. Okay. I guess the answer is going to vary. So let's pull this piece out. Okay, and I'll do that. Hopefully it'll extract a variable. Oh, come on. Okay. We'll call it answer or expected. That's usually what I say. And expected is an, well, actually, let's make it an end. Oops. Okay, so we're going to plug in that int. All right, this thing we expected a 1. Is 10 less than 10? We expect a 0. Two, 3, 4, 5, 6. All right. Less than or equal to? Not equal. Greater than. Oh, I lost one, didn't I? Greater than or equal to. Okay, we do equals. Let's do not equal right after that. Oops. 1, 2, 3, 4, 5. What did I leave out? Equals, not equal. Oh, I lost less than. I guess I edited instead of duplicating. All right. 10 not let's see, equals should be true, not equals should be false, less than should be false, less than or equal should be true, greater than should be false, greater than or equal to should be true. Okay. And I don't know, I'm not testing it exhaustively. We'll see how we feel. Okay. Another way would be to pair the operators, pass both the operator and the opposite, and run it both ways. Might be another option. Okay. This hasn't really passed because we added a bunch of stuff. It should fail. First one's fine. Second one should fail. All the ones should be. Oh, okay. Yeah, that's correct. We have a set of operators somewhere. Here we go. Um, these define how do you actually process this operator. Okay, so not equal is 0 not equal to 1 goes to 1.0 else 0.0. Okay, and less than. And yeah, I guess these all have to do something like that. $0 less than $1. $0 greater or equal to $1. And the dollar sign stuff, if you're not used to that, this is a closure being passed in. Let me finish the typing and then I'll talk. Okay, so we're basically passing in this function. We're saying this is a map from tokens to functions. The function is 2 arguments and it returns, 2 floats and returns a float because that's what BASIC does. Everything's a float, even logical ones. Okay, so the first argument is called $0. The second one's $1. You can also name it. I could say x comma y in, and then use x and y instead of 0, 1. But this is common enough. Don't worry about it. All right. Let's see if this passes. We gotta go back here. Should. Okay, and let's do some cleanup here. All right, so I think I want a little helper that does this bit of logic. Okay, so let's see if we can extract a method. And I guess this is bool to float. Oh, how interesting. Where did it go? Okay, we'll name it X and Y here. Okay. So okay, good. So well, that helps the 1, but the expression up here buries in the equals operator. So let's add that operator, and we know what its type is, right? It's going to be it's going to be like this. It's really Boolean. We're really doing the Boolean operator equals and not equal. The relational operators, sorry, they return Boolean in Swift. So we need to pass in. Let's do it here. Op is this type. Okay, but really it's bool and bool. Oh no, it's float, and float goes to bool. That's what I want to say. Okay, and I think just to help the readability a little. And I don't know. I kind of like an extra. I'm not sure what the standard style is. So I'm just saying x op y here, and then I have to pass the operators. Well, this one was equals, and I should be able to pass it like that. I'm hopeful. Yeah. Okay. So again, I'm using this notion of a function. In Swift, the operators are also implicitly functions of two arguments and producing a result. So I can do this here too. Float $0 not equal $1. Okay. That should be fine. Oh, is it not like... Oops. Commas. Okay, less than is bool to float $0 less than $1.
Mr. Brown can move, not his cow.
Okay. And here again. And I'm just kind of nudging away all this duplication. I'm just kind of, I can modify it in one place if I need to, and that's a good thing. And hopefully it's conveying more. I mean, it almost reads. Okay, fine. And one more. Bool to float. Sorry, there's a little background noise. Okay. So that should do all those. Our test should still pass. Let's run them all just to feel good. Okay. Yeah. What test failed? Test print with comparison. 1 is not equal to 0. Not equal. Oh, did we? Okay, so we said 10 not equal 10. Oh, that should be false. But we got a 1. Okay, let's make sure we're not equal. Bool float not equal. Okay, if you see it, say something. I don't know. That looks the same. Equals bool to float 0 equals $1. Bool to not equal bool to float 0 not equals $1. All right. I guess do we want to break? Why is there some? And our bool to float. Oh, shoot. Wow. Okay, we're definitely going to test this more thoroughly. Okay, we didn't apply the op. I think I have to say op xy actually. Op xy. Heck of a thing to forget. Okay. Only one test caught it. That's interesting to me. I mean, all the ones with 1 should be fine, but I would have thought these others would not. Okay, so let's modify our tests. And this is another, well, yeah, so I think what I want to do is do I want to make 2 lines? I don't think I parsed 2 lines yet. Oh, let's see. Trying to think of an easy way to get this in. So, excuse me. What I'd like is I'd like to say check. Well, let's do it. Let's say there's a I'll say file private because it really is a helper. File private function check. Rel op, and it's going to need the first operator, a token, op1 of token, op2 of token, and op1 expected of float. And I'll make this like that. Let's do the formatting again. Part of it's just these short lines, but that's okay. There's definitely a style that doesn't mind. And I don't know, I think that looks better, but I don't think that's Swift style. Okay. So what I'm saying I would like is I'm gonna kind of do this. I want to do check with print with rel op, and I want to do op1 and expected. Okay, but then I want to do I want to do the opposite. And I think I think this will communicate to me enough. Hopefully it does to you. I'm going to do op2. Oops. Op2. All right, 1 minus expected. Okay, and it's either 0 or 1. You know, they're either 0 or 1. Well, I can do better, but okay, let's see if this works. And then check rel op. I'm going to do check rel op. Op1 is dot equals. Oops, what did I just do? What? Check rel op. Oops. Equals not equal 1. And now I got to pair them correctly, right? So not equal. Okay, let's make sure that works. Okay. Let's do the others. Check rel op less than, and the opposite is greater than or equal. Equal to and 0. This one goes away. I'm going to mark this one. Oh, it is file private. Okay. Less than, greater, or equal to. Greater than goes with less than or equal to. Okay. And this one goes away. Okay. This should pass. Okay. Now I'm gonna improve this result. I'm gonna say this is op1 expected true, and this is op2 expected false. Okay, and I'm not gonna pass this int. Okay, and then I will op1 expected is true, op1 expected true, we expect 1, and then op1 expected, op2 expected false, we expect 0. Okay.
Yeah, Grandpa's working. Let's let Grandpa work.
Little one running around. Okay. So now, I think this is better. Op1 expected true gets a 1. Op2 expected false gets a 0. That's really the true thing we're trying to say here. Okay. Again, I'll squeak that out and make sure it looks all right. Okay. And test. Okay, so much for that. Let's see. This one fails. Less than expected 0. Oh, I have to. Yeah, I have to take them into account. 10 is not less than 10. Okay. Greater than. Less than. Okay, and 10 is not greater than 10. I don't know why that one didn't fail. 10 is less than or equal to 10 and is not greater than 10. Okay, so something's still not right. No? Okay, good. All right, now double check. Make sure we believe it. 10 less than 10 equals 10, yes. So 1, 0. 10 not equal 10, 0. 10 greater than or equal to 10, yes. Less than, no. Less than or equal to 10, yes. Okay, I'm happy. All right, so we added relational ops to interpreter. Okay, and let's go to our to-do. Relational operators. All right. Now, we saw something that says exponentiation has higher precedence than unary minus. And I'm very sure we don't account for that. Let's find the parser. Parser. We'll go down to factor, which is where we handle unary minus. Okay, so okay, if it's a token is minus, then we try factor. So this assumes minus 3 cubed is minus 3 cubed. But that is not what they want. Okay, so wow. I think this can work. Let's see, where's exponents? Term, sub-expression. Oh, did we not handle exponents yet? Oh, there's exponent. Okay. Exponent is higher than, yeah, we're going high. It's funny because we talk about low to high, but then I guess that's the way the grammar goes too, low to high. Usually they show you the high first and then the low, I guess, right? So let's see. So a power, and here's our grammar down here. Term goes to power, goes to factor, to the factor. But I guess it could be how do we want to do this? This needs to come in higher. it can either be factor or minus power. I think that would be this grammar. Power. Okay, so if we did this, if you came in here and you saw a minus, you would capture this stuff first and then put the minus on top of that. That seems right. If you did power again, you could do minus minus, right? And that would still be minus, comes in with minus, and eventually gets down to the factor level. All right. So I think this is the grammar we should have, and this is the grammar we have, but it's going to be, this code is just going to show up somewhere else, right? Okay. So, oh, let's write the test first. Okay, so addition, subtraction, multiply, divide, powers, left associative. Okay, that's good to know. And then let's see. So what we have is a situation we did not test. So unary has precedence over power. Is that the way to say it? Unary minus. Okay. So minus 3 to the 4th is minus applied to 3 to the 4th. And I kind of convinced myself that's what we would get because power gets parsed before the rest. Okay. And let's do this again. And I don't know, with these compiler kind of tests or interpreter tests, there's a lot of duplication across tests. This is a throws. Okay, so we want to make sure minus 2 to the 3rd. Actually, this is probably a better test. Keep the whole thing there. That should be minus of 2 to the 3 to the 4. And not minus 2 cubed to the 4th. Okay. All right. Now, the expression .make is not going to be enough. Well, let's start here. That'll get us something. Okay, make expr.make. Let's find that. We may have to build our own. Oh, we have this one. Yeah. Oh, but it's obtuse. Okay. Yeah. So this is able to build number operator number or three numbers. Okay. We need a make unary kind of thing to kind of keep up with this. So static function make, and whoops. I don't know why that got put in. Okay. We return expression. Okay, and we need an opening brace, and I don't know what that junk is. Okay, so what are we going to pass in? Well, we want to pass in a unary op of token, and then a number, and then its binary operator. Also a token, and then a second number. Float. Okay, so if you had a unary operator applied to number binary op num, what we expect is, well, op1 applied to unary op and op2, well, that's it. This is actually this. Okay, so op1 applies unary operator to the result of binary op applied to number 1, number 2. Okay, and one more parend. Okay. Yeah, so we expect a unary operator applied to the result of two binary operators. And this is make. Our unary operator is minus. We don't need that. And this is 2. This is 3. Okay, what I really expect the answer is going to come back with minus 2 cubed. Okay, so it'll have the same pieces, but they'll be in a different order. All right, it's hard to read. Okay, so we got op2 exponent of op1 minus applied to 2, and the exponent also applied to 3, but we expected the op1 on the outside. So at least the current way, this reveals that, yes, we are handling minus down at that level instead of up at this level. All right. Usually we take a break about now, so let's take a 3-minute break, and we'll come back and make this test pass. I don't think it'll be too hard with this grammar rule in place, and move on from there. All right, see you in about 3 minutes. Hi, welcome back. All right, so we've got a failing test. It's got the unary operator at the wrong level. We have a theory on how to fix it. We're going to take that rule off a factor and put a similar rule on power. I think we will start with that rule, actually. So if this thing starts with a minus, and I'll move this up just to kind of make that more clear. If it's a minus, then we're going to try power instead. Minus goes to power, and then we return the unary minus over top of it, okay, like we want. Otherwise, we're going to try the usual factor to factor kind of thing. Okay. So let's run the test. I think that's looks correct to me. All right. And this is where being grammar driven just makes life pretty easy. You know, it really helps. Okay. Precedence, low to high, relationals, nots, ands, and ors. Okay, so let's get and working or not working. Well, actually, let's see. Find my picture here. We normally have to do all three pieces: scanning, parsing, and interpreting. In this case, we don't have a not, and, or tokens, so we have to scan first. And I may take this moment. I had some ideas on making that a little more straightforward. Lexer tests. And let's find the Lexer. Oops, I got a little buddy here. Okay. REPL, we want Lexer. Lexer back here. Okay. We've done some stuff. We pulled out something for these single tokens, but we also have the reserved words. Okay, so there's matching numbers, matching operators. Here we go, starting the letters. Okay. The way it is now, we're we're basically gonna run through this possible values. So we could add something that says if when maybe we should if value starts with and, then yeah, that's what we got. Okay, so basically it pulls um, it pulls all the letters, and then it checks that list of letters starts with the keyword. Okay, so I think the refactoring I want to do, again, I want to like pull these words out, and then mostly I think, let's see. I mean, usually, well, okay. Yeah, so this one's different. Remark is different. Rem is remark. Okay, good old basic. Remark is skip everything till the end of the line, but really it could skip word rem and then handle it. So let's drive these to be more similar. Okay, and um, okay, and let's yeah. Okay, so I'm gonna say that if you skip word rem, you've everything should still work because we're just ignoring it otherwise. Skip is sort of an ignore as well. Okay, now let's um, let's see what we have for tokens. We have an unknown. Let's let's add one. Case unknown. All right. Is that gonna build? There may be somebody switching on all these. No. Okay. Good. Um, I'm gonna say var token equals unknown. Okay, so now I'm gonna pull the returns out. Okay, and instead of returning it, you're gonna say token equals, and same thing here, token equals, and then if token not equal to unknown, then we're going to return it. Okay, so it's a little awkward. Okay, token unknown. Okay, so I've set token to unknown. If I find something, I'm going to do it. Okay, let me turn this into well, let's run tests, a little small step. If I find something, I'm going to return it. If it starts with rem, it can't really start with print, so there's no chance of overlap there. If it's not unknown, then it means I found something and I return it. Otherwise, I do what I always did, which is return an error. Okay. Um, Now this, because they are exclusive, I'm going to just turn this into an else if. Okay. And again, okay. All right. Now, if here's most reserved words, they don't act like rem. They just do their job. They just match the word and they're done. Okay. It's rem that's the funny one. So I'm gonna pull that case out here. Okay. If token equals token dot remark, I probably can just say dot remark here. If it equals remark, then I'm going to do the ignore until. Okay, so I'm switching the order of capturing the token and the ignore until to drive these other reserved words to be more similar. Okay, so again, that's pure refactoring. There should be no change in behavior. Okay, now, um, Let's look at the reserved words. We want to find, does any reserved word, um, do they overlap? So if I had def and define, they would overlap. But I think the way basics define themselves, they don't allow that. There is no example of that. Okay, so um, I mean, go to and go sub start the same, but there's no go that would be confused with them. So the order of doing these things doesn't really matter. Okay, so let's make another definition. And this is going to be, let's map um, reserved words is a string, and otherwise it's a token. I mean, the value is a token. Okay, so I'm going to build a map, and we know rem goes to remark, and print goes to print. Okay. There's certainly nothing wrong with creating that. It's so trivial refactoring, I think I'll just leave it. Okay. Um, Now, instead of, I think I have a pattern that's, um, I could walk through my statements and find one that matched and then do a skip word on it and save the token that it had. Okay, so let's do that. So, reserved words. Now, if we, um, there's a find first. Find. Hmm. Well, I can do for each. So let's start there, and then we'll. Um, okay, so if I run through each reserved word and I did this, okay, if value is $0 because it's a closure, takes an expression. Okay. November starts. $0. Well, this is let's do word token in. Okay, and then I can reference word. Oops. If value. Oh goodness. Value starts with, here's the reserved word, is word. Okay, then we're going to skip the word. And assign the token. Oh, token is a let. Oh, this is let's make this reserved word. Keyword equals token unknown if keyword. Okay, sorry. Let's use the tool. Maybe it'll do it. Rename this to keyword. Okay. Now, if value starts with word, yes, skip the word, assign this to keyword, and this is the token. Okay, so let's. Oh, okay, good. Let's compare this to this. So, because it's a dictionary, it's a pair of the key and the value. In our case, word and token. If the value starts with the word, like rem, skip the word rem and then assign keyword to the token. Okay. This is a little. I mean, it's going to run through all the words but they are different, so it should be okay. All right, we'll comment this out and run them all. And this should just be working. Yay. Okay. So, I mean, again, that's a pretty good sized transformation for something like this, but I find myself doing this thing a lot. I've got a couple examples and then kind of put it in a table and make stuff work from there. Okay. Let's see. So, if I have the reserved words, okay, value starts with the word, match the word. Okay. Now this could be, we could, okay, let's simplify this a little more. Let's start with this as a default. Okay. Keyword is going to start out being unrecognized name, but if you come up with one, then that's fine. And I don't think we need to check it now. Okay, because if it wasn't a keyword wasn't set, it defaults to that. So we can just let that be the return value. Oops. That one's okay. These two are not. Okay. So now the keyword starts out saying, I don't know what name you're talking about. It looks through all the reserved words. It finds one if it can. If it happens that it was remark, then there's special actions to take for that one, unlike most others. And we return keyword, which is either the one that got found, or if none was found, it's this. All right. Let's do this. Clean up a little bit. All right. And again, that should just pass all the tests. Okay. And I'll check this in. So what we did was we refactored keyword processing to use a map and a loop. Okay. And we'll push that. Now, my feeling is there's probably a way to do this in one loop, not mess with this stuff. Let's see what I can say. Reserved words dot first where. Okay. Yeah, that's what we want. Okay, so let's see if we can use that. So we want to bump out of this loop at the first sign of that. But I'm going to have to check it. How would I know I got there? Okay, so if I skip forward until I find a matching one, maybe that works. First, I think returns it optional. First where? Let's look at the type of that. Okay. Rethrows. Key string value token optional. Okay, so it finds the first one that does that and returns that or nil. Okay, and then we can do a default value. Okay, so if I'll put this in parallel first, and then because there's only one argument, we can just put the closure. Okay, so the first where let's do this part. Word token in, okay, value starts with word. Okay. So this says run through the list. Oh, am I one too many? Result unused. Okay. Yeah. So run through the list, find the first reserved word that starts with the word we have. Run through the list. Um, if our value, oh, value. Oh, value is our matched repeats. Okay, and it's a string of letters. Okay, if the value um, starts with the reserved word, then we're going to return that. Otherwise, we return nil. Okay. If we get one, let's see. Okay. And I wish I had automatic help on this one. IntelliJ in Java will pretty much work you through the pattern for this. It recognizes, hey, you did a for each with an if in it. You could just do a for with a filter or something like that. Okay. All right. Sometimes it's better to just get the list of them, and if the list is empty, then you don't do anything. Okay. But anyway, so I've got a pair, right? The type of this thing is an optional dictionary entry. Okay. Um, the basically the pair of the word and the token. Okay. Where the value starts with the word. Okay. Now, if I think, can I just do? It's not for each. Oh. Hmm. I'm not mapping because I'm not what I'm producing. Ooh, I'm consuming stuff too, so I'm modifying the world. So I don't want to be too coy. Is that the right word? I don't want to. Um, I don't want to lie about it. Okay, so this dot custom mirror debug publisher. That doesn't sound like what I want. I thought there was like dot value or default. Okay. Well, I could look at answer. Then I return this. And we'll see if I like this better when I'm done. Okay. So I'm trying to replace that block. If down to here. So if you did not find an answer, result of call to function returning token is unused. Oh, this is a return. Okay. If you don't find an answer, return that error token, which we're going to do more work later, so it's okay. If it's not nil, if it happens to be remark, then we're going to ignore until. Well, actually, I still have to do the body here. Let's get this stuff. Okay. If it's not nil, then I want to skip word of answer. And this is, because it's a pair, this is dot 0, this is dot 1. And I know it's not nil because I just checked it. I thought it would do that for me, but okay. And then down here, keyword equals token. Well, okay, yeah, let's do that. whoops, keyword equals, well, this is the right one. So answer bang 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 dot one. Okay. Um, so we're gonna skip the word, then we'll check it for a mark and do that. So my theory is this replaces this. Actually, it replaces this. Better or worse? I don't know. Um, let's run tests. Otherwise, I'll just revert it and go away a little smarter about my limitations, I guess you'd say. Okay. Um, and I leave it this way because I do feel like there's probably an even better thing. Like there's something or default. Let me look at documentation. Let's see. I've got a spare window over here. Oh, let's get another window. Okay, Swift. It's like, what is it? It's value or default? Value or default? No. Yeah, this is. No, that's not what I want. I mean, that's useful, but it's not what I'm after. Or else, yeah, that may be. Let's try Swift first example. Swift set first, array first. I don't know if we're going to see it. Okay, first, that's not quite what we wanted. First, where? And part of the problem is these, everything is so, the words have been used over and over for different things. And okay, well, let's work from the map dictionary. Okay. Is empty, subscript, random element. Filter. Okay, but yeah, this is where we could have filtered down to an array of matching items. The nice thing about first is it stops when it finds one, but that's not bad. For each enumerator to make it. Okay, contains. These are first where. Key. Oh, the index. Okay. I think I'm mixing in an Elm thing and hoping it's here. Well, let's go back and check out array because we could get an array back. I mean, Elm is much stricter about making sure you don't have nils. I think that's what I'm doing, is mixing that up. First index, we don't care about the indexes. The drops, yeah. So I do wonder if, okay, let's try something. Can I do a map here. No, I decided I couldn't because I'm modifying stuff and I don't want to mix that up. Because I do a skip word when I get out. Okay, let's stop there. Not for the day, but stop this path. All right, so we changed the way we scan through reserved words to stop on the first match. Okay. Now, we set out to do and or a not, and this is, I don't know, how do I want to call it? It's opportunistic, maybe? I think we could get all these reserved words and just get them done, all right? I don't know about these functions, they're a little different, but not and or, and the statement ones, we ought to be able to do that. So let's do that. So I'm pushing the scanner further ahead because I think I've got things to a point where they, how do I want to say? Well, basically, I think we're to the point where it's like create the token and fill in the table, and it all works. Okay, um, so that that to me, it feels like, oh, we can just get that done and be done, and let's do that. Okay, so we got token. Here's our reserved words. Okay, so we have clear and data def dim, data def dim, end for go to go sub. I don't know if end is a for, okay, for keyword. Okay, and I think I'll group these a little bit. For go to go sub, if go to, well, that's okay. If then, if, and I know that's a reserved word. And down here is then. Okay. If then input let next on. Input let next on. Go to go sub recovered, poke print read rem. Case poke print read rem. Restore return stop. Okay. So we have all the words. Let's put them in our table. And maybe, I guess I can, what can I do? I don't know. It's almost like it's by inspection. I don't think there's a lot of extra value in this at this point to do them all one at a time. Let's see. I know, well, sorry. I think Xcode has some of these editor things. Let's see. I'm looking for something that lets me do multi-line editing. Okay. Let's search that. Yeah. And geez, this was option click. Oh, it is. Okay. Shift Control left mouse click creates a new cursor on every click. Shift Control arrow. Option drag will create a cursor on every line you drag. Well, let's try that. Ah, that. Okay. Now, where's my cursor? And nope. Undo. Okay, 1, 2, 3, 4. Well, dot. End of line, comma. Okay, there. You made your money today. One nice trick in Xcode. All right, now I'm going to put the words. I guess I'll just type them. Go sub. If, did I lose something here? Go sub. Okay, I guess I didn't. If input stop, then, and we should still see print and remark going to the right thing. So there. Okay. Yeah, I think I would say I'm relatively confident that this will do the right thing. I am not. If it doesn't, then if it doesn't, it'll show up when we start parsing and when we do our interpreter. The commands just won't work. Okay, so I don't think there's any extra risk in doing this. Nothing should fail, but I don't think, nothing we did should change any of that. Okay, so let's see. We added remaining reserved words to flexing. Not flexing. No, we missed some. Okay. Add reserved words. Okay, and since we missed some, let's add them. And or not. And keyword. Oh, actually, is that needed? Maybe not. Case or. And case not. And then our lexer. tests. Alrighty. Okay, so we've added reserved words. I guess I can say all reserved words, right? All reserved words to Lexer. Okay. Now, the next step we want to do is get these precedence things right. Okay. Well, and or not, that's one unary and one op1 and two op2s. But let's get to the parser. Really, our grammar needs to deal with it. Okay, so relational operator, the lowest precedence is or, then and, then not, and then rel up, right? I think that's what we said. Yeah, lowest precedence is or and not rel. Okay, so the effect of that is the lowest precedence has to be first. So this is what is this? This is really a relational expression. So we'll extract a method. Relational expression. Okay. And I've been going in the other order. Oh, interesting. The extract method did not do a complete job. It goes up here. Okay, and I'm going to pull this below, trying to tell a story top down. Okay, so if right, so relational expression, this is just a pure refactoring. Let's check it in. And I really wish I could just bump a button and it knows, like, you know, oh, you did an extract method. Relational expression. I'd really like my automated refactorings to just auto check in if they pass their tests. But you did see a fail, an Xcode bug, right? We had code that was valid. We extracted a method and it was wrong. Okay, so the tools aren't perfect. I mean, I wish they were, but they're not. Okay, now let's define more grammar. So we have expression. Well, this is really relational expression. And now we had expression goes to relational expression. Okay, and you can see that because all it does is call it. All right, but now this is a place we can put in not. Okay, so expression, let's go to negation expression. Negation expression, maybe just negation would be enough. Negation. And negation goes to relational expression. Okay, that would be a valid refactoring of our grammar, and then we could do that over here. That makes me think relational expression could just be relational and not mess us up too much. Okay. So we'll just duplicate rather than fight my way through a failing tool. Okay, so this is negation, throws, exception. This one is going to go to negation. Okay, so now we have expression goes to negation. Negation goes to relational. And the rest of it beneath is unchanged. Okay, so now in negation, it is either not a negation, or, and you're seeing another unary, so that's why it's following this pattern that we had before with the minus, not negation or negation. Oh no, is that, or relational? Yeah, sorry. Yeah. Okay, so that's what we think it should be. All right, and let's make a test. Let's see, power, addition, relational. Okay. This is check. Oh no, it's test negation. Okay, and I think, where's our unary minus? That's probably a good model. Okay, the program is not 2 less than 3. And this is really relational, has precedence over negation. Okay, because this should be interpreted as, and throws. This should be interpreted as 2 less than 3 with a not on top. So this is not 2 less than 3. Okay, so not 2 less than 3. Parse, let's check. And I'll just run the class. Should fail. Okay. Okay, yeah, so it says I thought I'd get a number or left parenthesis. And because it found the word not in front, and it tried all the leading things. It's not a minus, it's not an integer, not a number, so it failed. All right, so we need to make it parse not. All right, parser. Okay, this is negation, and it comes first if equals not, then we're going to well, let's find that minus again. And these patterns. Okay, it's very similar to this. Actually, I don't think we need the case there. If dot not equals token. Oops, did I? Okay, it's a little backwards to me. Yeah, it's the way it likes it. Okay, if we have a not, well, the operator we're not going to try power. We're going to try negation again. And we return op1 with not on value. Okay, so value try negation, not negation, op1 not. Okay, otherwise we go to relational. And I think I'll believe it's working until proven otherwise. Okay. Added not to expressions. Okay, and that's that one. All right. I think we're due for another break. So we'll come back and we're going to add and then or. All right, so another 3-minute break. Hi, welcome back. All right, we're going to handle these last two cases of and or. All right, and so we'll do the same kind of process. So I don't know what to call it. I'll just say and. Expression goes to negation. Okay, and now it's more like this one. Well, either one of those. It may have and negation. One or more, or zero or more examples of that. Okay. And so you either negation or you have negation and negation and negation. All right. And a test that's even lower precedence. Does that seem right? I guess it does. You want A less than B and C less than D, and is in the middle. Okay. So test and expression. What is? It's not conjunction. There's a word for it. Okay. Let's see. So it's more like multiply. Well, maybe we need to. Let's find our make and see what we got there. Numbers. It's not quite a match because we need. Well, they are floats. This is really like 1 plus 2 times 3 kind of thing. Or 1 times 2 plus 3 would fit this. It's actually legit to use numbers for these things. All right, but let's build up the whole tree. Okay, so we'll take this and then adjust. Okay, so if the program is 2 less than 3 and 4. Okay. And there's some ambiguity there. The actual interpreting of that, I'm not 100% sure. Okay, this actually does fit our make, I think. So this should be make let's see. What was the operator 1 2 thing? Okay, num1 operator 1. Okay, so that's 1 less than 2 and that. Okay, so operator 1 is the interior. Okay. That's let's say 2 less than 3 and 4. Okay, and this should fail. We've got our token, but we don't look. We don't look for and yet. Okay, so we got less than 2, 3. It didn't know what to do with the and. Okay, so let's go to the parser. And again, this is going to be very similar to these. So similar, I'm just going to copy. And yeah, maybe sometime we'll do that. Okay, so let's put in a new function, and expression throws goes to expression. Okay, and that's that. Okay, so the left is not a term, it's a negation. Okay. The repeat is a negation. Okay. And it's while token equals and. Okay, so left is a negation. While we have ands, we consume the token and save it. We don't have to, but it's similar. Okay, we try negation and that, and I think that's good. And now we need to call it. Okay, and I believe all tests will pass. Okay. Add support for and to parser. All right, now the last piece of this. All right, let's do an or expression. And or expression goes to and expression or and expression star. Okay. And again, I'm just going to copy this because it's so darn similar. Oh, I guess I should make the test first, eh? Just so let's do. We're gonna have to make a fancier test for this one. All right. Func test or expr. Okay, I guess this stuff is more or less the same. That's gonna change. Okay, so if we do 2 less than 3 and 4 or 5, okay. Actually, we can just do numerical stuff for these. That's fine. 2 and 4 or 5, we expect the and to have priority. So let's swap it. 2 or 4 and 5. Okay, so kind of like addition, 2 plus 3 times 4, we're making sure that you don't do 2 plus 3 first, so we're making sure you don't do 2 or 4 first, okay? And then the expression, the or is on top. I think we've always had the one with the second one on top, so I hate to... There should be a better way to do this. Let's get it going and then we'll figure out what would be better. I think maybe I can make a sort of prefix form expression and build something that looks like a tree here that might be less wordy than the real one. Okay, but at any rate, We expect to see, well, we don't expect an expression like that. We expect to see op to the or is on top. I'll put it on different lines. Or, okay. And then inside there, we expect an up to that is, oh, maybe I can make my old friend. Let's try that. Make two all right, let's look at this again. Okay, so it puts operator 2 on top, so we're going to have to make the operator 2 be the or. Okay, so 4 and 5 or 2. No, that can't be right. The 2 has to come first. Okay, so I'm going to have to do it the other way. Yeah. Op 2 or I think it's token number. Yeah, just that number. Number 2 or op 2 which is an and with number 4 and number 5. That, good. I don't know if it'll format nicely. Well, I don't know if I can do any better than that. That looks pretty good, really. Yeah, I think that's pretty good. Well, okay, let's make sure it passes. Oh, well, it should fail. Okay. The assert probably doesn't have an or in it, right? Number 2, yeah, didn't know what to do with the or. Okay, so parser will extract out an or expression. And for now, we'll do this. And this becomes or expression. Okay, and this should still fail. Okay, and we're going to replace it with and expr here and here, and this token is or. Okay, so left is and expression, get the or, try more and expressions while you can. Okay, and I expect to pass. Okay, well, that's a milestone. Okay. To do, we did these. Okay, so there's two things I can think of missing in our expressions. One is that you can have variables, and normally that would be a factor, like down at the bottom level. We support subscripts, and we also need to support strings. Okay, we've done all the operators. We're making progress. We've got all the reserved words. We've parsed all the operators. We haven't parsed variables. We haven't evaluated operators, which we should do. Um, we haven't dealt with functions, but functions also are down at that bottom level. So it's going to be the factor could be a variable followed by a subscript or a function followed by a subscript. Now these. How do I want to deal with that? Those functions, like, do I really want to have one keyword for each function name? I kind of don't think so. But maybe they're a case after the keywords. They're not really keywords, I don't think. They are unique to them above. Okay. Well, the variables. The thing is, we don't have an assignment statement yet, so you can't actually define any, or if you use them, they're presumably zero or something. I don't know if they bothered zeroing them out, but we probably can. All right, and we haven't done evaluation, so maybe let's just do evaluation. That may take enough time that's kind of the rest of today. Okay, now these things, not is an integers to complement. Okay, so what I take this to be is that these operations are the integer ones, and this lets you do manipulation of bytes and stuff like that. There are definitely places where basic converts stuff back to integers, does something, and then turns it back into a float for you. Like, all right, let's see if we. Yeah, here we go. Logical operators. Okay, so we talk about semantics, right? I'm reading this to figure out the semantics. Logical operators produce results other than -1 and 0. Any non-zero result is considered true when testing for a true-false. Okay, so it's like C in that regard. To modify the meanings or to produce an arithmetic results. Okay. Yeah, logic operations can also do bit operations. Only on a single operand to the right. Yeah. Okay. They get worked on as 16-bit integers and do bit correspondence the way you'd expect. Part of the weight statement. That's not in our version here. There's no weight. Okay, specify Boolean operation performed on two operand expressions on either side. Case of not, only the operation on the right. Yes. Aren't performed until all of those have been completed. Okay. Now, okay. Yeah. So we have some work to do. Okay. Let's see. So I can move this away. Again, now we're working on the and, or, and not in the interpreter box. We finished the parsing box. Okay. So I was a little premature to move these because we haven't interpreted them. All right, let's find our interpreter tests. Okay, so relationals produce 1 or 0. If you do ands and ors on 1s and 0s, everything's fine. If you do them on fancier stuff, that's legit. Okay, so print with value, print with unary minus. Okay, so I think let's do a moderately complicated expression. Okay, yeah, I guess down in here, unary minus subtraction. Okay, let's do test logical operations on integers. Okay. So if we let expression equal, well, let's see what we want to do. We want to do well, let's do not. A not has the highest precedence. Okay, so let's do not -2. -2. Well, I shouldn't have to say that. Okay. Not is higher than umbrella. I'm just going to do arithmetic. Not 2 or 5 and 4. Okay. And you'll forgive me if I put these into bits. Okay, so -1 is always 1, 1, 1, 1, 1, 1, 1. -2 is 1, 1, 1, 1, 1, 1, 1, 0. Or of 5 is 101. And of 4, these are all zeros leading on these. Okay, so I expect my result to be 1, 0, 0 equals 4. Okay, not -2. I expect that to be flipped first. Sorry, not -2 is, I may need a, zeros, -2. It should flip it to 0, 0, 1. Let's make it not -3. Is this okay? The rule is complement and add 1. Okay, so zeros 1, 1, 1, 1. Okay. So I want to make this a 1. Binary. Okay. Not converting it to the opposite. Normally you complement and add 1 and you get the positive version. We're just complementing. Oh, so I do want this. Okay, turns into 1, 1, 1. with a not, and the result is 4. But this, I gotta, if I complement this and add 1, that's 1s, 2s, 4s, no. 1s, 2s, 4s, 8s. This is 8. Minus 8. We're going to check my arithmetic. Okay. Minus 8. What's that look right? Well, 1s is minus 1. 2, 4, 8, I guess. Okay, hopefully we'll see. But that's the expression we want. And we're going to feed in the expression itself. So the expression is, remember, or has the least precedence. So it's the outer operator. Okay. And inside it is a unary. Well, a not op1. Oh, and the operator is or. This one is a unary with dot not and number minus 8. Actually, it should be another op1, right? Op1 dot minus dot number 8. Okay, so that gets me this. Close off my not. Next argument of the or is an op2, which is and dot number 5 and dot number 4. Okay, no reference. This is expression dot op1. Oops. Dot. Okay. Sometimes you just have to tell it. Oh, I probably could assign it. Let's see. We did some of these with just expressions down below, right? No, we really didn't. Okay. Let's pull this. Parse equals line, and then this. Let's let expression equal this. The bigger these get, the worse it gets, huh? Okay, so now I want to do, instead of this expression, I'm just going to do expression. Okay, and I think you can read that on one line just as well. Okay, so line 40, print expression, and we expect the output to be 4. And minus 8, not minus 8, 5, and 4. Okay, now I'm going to keep this comment because right or wrong, it's definitely how I'm thinking about it. Okay, not minus 8 or 5 and 4. Okay. Print that. Don't need that. Expected member name. Did I lose a print? No. Okay. Whew, this should be our worst test. And I'm kind of throwing everything at it because it should all just work right now. Yeah. Okay. Our operators. Control. Okay. We don't have an and or an or operator yet. Or not. Okay. Um, wow. Well, not let's make them live for now. Let's -7 and not complaining. Not. I think it's this. Oh, he only takes one. Oh, he's a unary operator. Interesting. Okay, let's see this one. Let's do the and or at least. And is well, it takes two operands in minus. Let's say 42. Well, let's do something we can work with arithmetically. And or is this in 8. Okay. And where's our unaries? Okay, if token equals minus, return minus. Okay. Let's deal with the op1. And maybe I should be doing the same table-y kind of thing. But let's just do else if token equals dot not. Return operand. Okay, and this is a TBD. And all these are TBDs. I'm just putting something in there to satisfy the compiler. And hopefully fail. Okay. So our interpreter test should no longer get this fatal nil. Oh, if I could type. Yeah. Update to recommended settings. Okay, whatever. All right, well, where's our failure? Aren't you supposed to have a little thing for me? There it is. 8 is not equal to 4. Okay, so the 8 came from the or. No, yeah. Did it? Or, yeah. And notice that or is our topmost thing. So at least something is coming from inside the system. Okay. Let's see. So I think we're going to work our way from the inside to the outside. So let's do the not first. Okay. The message is wrong here now. It's not a unary operator, let's say. Okay. Somebody may be checking that. We'll live. All right. So the logical not, boy, if okay, well, we're going to take the value. Let short equal short of operand. Okay, is that going to let me do that? Okay. Not find short in scope. Okay, let's find our Swift data types. I guess int 16 would be our short. Okay. Okay. And then we're going to return, I think Swift uses this. Is that, let's check the operations too. What did I do with that? Numbers and numeric types. Let's try Swift binary operators. Somewhere they'll get a table. Yeah, we got all these fancy ones. Bitwise, that's what we like. PXOR, they don't mention. Oh, there we go. One's complement. Okay, so that's what we want. All right. Except for one's link problem. Oh, yeah, okay. A little short, we got to convert it back. Okay, so interesting. All right, well, this shouldn't change anything except we might find a message that's wrong. Okay, logical operators down here. Probably still getting 8. Yep, okay. Let's go back here. Okay, I think that one's right. This is the problem of doing them all. Okay, let's do OR first. Okay, so we're given $0, $1. We need to do the same kind of thing. Let short 1 equal int 16 of $0. Let short 2 equal int 16 of $1. And return float of short 1 and, or short 2. Okay, and I may as well do the other one too. Okay, I will format. Okay, so short, convert it to a short, and does the binary and, or logical bitwise and, bitwise or, okay, and we're hopeful. Okay, what do we get? Interpreter test. -9. Okay. Ooh. I'm going to have to break this up and do it slowly. I'll let myself debug it, I guess. Let's make sure the not operator's doing the right thing. Op1, let's break here. And we'll run just this test. Okay, so our operand, we find out if my binary arithmetic is up to snuff here. Operand is 8. Wait. Not. What was our test? Did we have a minus in there? Did I leave it out? Oh. Okay, let's try again. Fat fingers. Still. Okay, break there and look. This test. Okay, let's print operand. Oh, no wonder it's coming in there. Okay. Focus. Operand. -8. All right. And we step over. And we'll print short. I wonder what that message is. Step over. Okay. Let's print. Print not short. 7. I don't think that's what I put in my comments, is it? Oh, it is. Okay. So we got a 7 back. Let's step out. And over. Print operand 1. 7. Step over. Print operand 2. Is 4. Am I structured correctly? Or this is why you might like to do things in smaller steps, isn't it? Okay. I was expecting to see 5 and 4 together being higher precedence, not 7 and 4. Not -8. This is 7 or... Oh, it did evaluate. 5 and 4 is 4. Okay. Let's step over. Okay, and we got to look at the return value. Okay, value. I'm a little puzzled. Let's just continue. Okay. My expectation was 4. Somehow we got a 7. Oh, yes. I'm stupid. 7 or 5 and 4. Okay. 5 and 4 is 4, but 7 or 4 is 7. Okay. Okay. So I guess I'm happy because the system is better at this than I am. Unfortunately, the system depends on me getting the answers right to do it, or at least looking at the answer after it's told to me and believing it, which I'm much better at. Okay. Um, this is okay. This is 1-1. Okay, so it's the or. And if the parentheses implicitly are here. Okay. And expect 7. Now, this test, I'm probably doing this test at the wrong level. Let's do this. Okay, we have Bassy. Remove the breakpoint and continue. Good. Okay, so interpret a complex logical expression, making sure to do 16-bit bitwise operators. Okay. Yeah, so I think what I would say is the test, like this is the thing I'm testing, and I'm going through all this bulk screen and a half to do it. Okay, let's look at doing it as a programming language statement. So where's Bassy tests? Oh, should be over here. Bassy tests. Okay, these, they take the program, they run it, and they're working in strings. So let's do function test logical arithmetic. Well, what's the name we used over here is probably all right. Logical operations on integers. Yeah, that's a good name. Okay. All right, and I'll take this structure. The program is 25 print this. Okay. We interpret it, and the answer should be 7. Okay, this should pass. What do I know? Blank is not equal to 7. Okay, well, now we have a new problem. Okay, but that's okay. We'll know to start there. So, okay, print not -8 or 5 and 4. We believe it works out to the value 7. And it printed it. Huh. Okay. Well, sometimes you leave a failing test so you know where to start on the next day. And I think that's going to be our strategy this time. It's not obvious to me why we got an empty output. It may be something, we did some work around the REPL. Maybe I hooked up something in a way that makes this less meaningful or something. But empty is certainly weird. Okay. Thanks for joining me today, and we'll pick up there tomorrow. It's 9 to 11:30 Central Time, 10 to 12:30 Eastern Time, and 3 to 5:30 UTC. I appreciate you joining, and I hope I catch you now or in the future. Take care. Bye-bye.